Hi everyone, thank you so much for joining with me today. Today we are having the VN2 inventory planning competition, and we are very happy that Nicola Van de Putte is able to join with us on our channel. And so let's begin. First thing first, let's go through the agenda for today. First of all, Nicola is going to give us a short, brief welcome and introduction to the problem and the competition itself. And secondly, we are going to be exploring a little bit about Nixtla, our forecasting tool and ecosystem that will probably help you in your winning solution. And thirdly, to further explore Nixtlaverse, we are going to be sharing a series of starter notebook, which is going to showcase you how you can build an easy forecasting from start with Nixtlaverse. And last thing, we are going to have an interactive Q&A session. So if you have any question about the competition or about the Nixtla tool, please leave a message in the Q&A section in the Zoom so that we can be answering them in the end of the conversation. So first, let's welcome Nicholas, who is the organizer of the competition, to give us a little speech.
Thank you, Yimei. I'll try to share my screen to give you a small introduction to who I am and what I do with VN1. So you should see my screen, right? Yeah, it looks like it. So I like to introduce myself as someone who's genuinely passionate about demand and inventory planning. I've only been focusing on that for the last 10 years. I had a lot of fun. I know a lot of you already attending the webinars. Thank you so much for being part of this journey. I am myself, like everyone here, on my own learning journey. I started with machine learning models back in 2018. I really fell in love with the subject. I also worked a lot into inventory. Over the last years, I tend to focus more on demand planning as a process, how to help supply chain managers and leaders to set up a process. That was my latest book. And since then, I've actually been working on many inventory policies, and I changed the way I saw inventory problems and how to solve them. I really want to find the time to write a fourth book about inventory policies, but instead I did a class on Udemy about it. Maybe you were aware of this course on Udemy that reflects how I think we could solve inventory problems nowadays. But let's discuss the competition. Let me move. Yeah. So overall, I think that when we discuss demand forecasting, it's relatively easy to assess which is the best forecasting model or which one is the best forecast. It's not straightforward, but it's rather easy. We could have a debate about forecasting KPIs, for example. But at the end of the day, it's relatively easy to align on who has the best model. When it comes to inventory planning, it's much more difficult to assess which model is the best possible model. It gets quite difficult. The way I like to tell the story is, you can see on the right side of the screen, this is a picture of a bakery store in Brussels. I used to live right next on top of it, so I knew this one quite well. And when you think about forecasting, I used to have many chats in these kind of cafe with students or with some of the people I work with. I like to ask them, how many cappuccino do you think they will sell today? And if you say 10, I say 20, and they sell 19. It's very easy to assess that I was right or I was wrong. But when it comes to inventory management, if you ask yourself the question, how much coffee and how much milk should they store? If you say 20 and I say 50, and they sold 25 cappuccinos, we don't really know who was wrong and who was right. It's kind of difficult to assess. And because it's so difficult to assess which inventory policy is the best, I think no one was really interested into doing such a competition. And that's why I came up with VN2, which, to the best of my knowledge, is the first open global inventory competition. And I tried to come up with a way to do our best, even if it's not perfect, of course, to do our best at evaluating an inventory model. Because we're discussing inventory, we have to come up with a competition where you have to make decisions. So it's not just about doing a forecast, about predicting anything. It's about you have to make decisions, and you will do these decisions in your own, let's say, multiverse, where every single player will end up with a different supply chain, with different inventory position and so on. So you might have shortages, you might have too much stock, and every one of you will have something different. The way we will assess the best inventory model is by looking at the total holding and shortage cost. Quite often I got the question, why don't we use purchasing cost, minimum order quantity, transaction cost, and these kind of things? It makes a lot of sense. And from a supply chain standpoint, you most likely have minimum order quantity. You for sure have purchasing cost and transaction cost. So these make a lot of sense. But if we would use that in a competition, it would create some edge effect, meaning that at the end of the competition, around decision 5 and 6, people would stop to order to minimize transaction cost and purchasing cost. So actually, we would see some different models winning the competition because of these kind of edge effect. And to remove that, I focus on just holding and shortage cost. But I'm really well aware that it is not perfect, and I'm sure you have some other ideas on how to do such a competition. VN2 will take quite some time, so you have still until October the 21st to make your first order. So there is a lot of time left for you to come up with a model. I think you have 2 weeks left to make your first order. And after that, there is a bit of a delay in between each round. So you can see that there is nearly 1 week in between the first and the second order. So we're giving enough time to everyone so you can check on your model on anything you want. Talking about the data set, but I'm sure Nixtla will discuss this in more detail. There are 600 products. I think it's big enough for small machine learning, and it's small enough for you to do it in Excel. I wanted with VN2 to be super inclusive. You know, some people will do amazing model, quite complicated, super advanced, and some people will do this to learn. And I want this competition to be as open, as inclusive as possible, so you can try, even if you're just doing Excel and you just want to give it a try to learn. And you're more than welcome to join us as a learning journey. You can do this in Excel, it will work. And I wanted this to be feasible for as many people as possible to join. As any competition, I wanted to bring a benchmark, so at least you would know, well, with my technique, I'm able to do better than this simple technique. So unfortunately, first, there is no usual universal benchmark for inventory policy. So I just come up with one. My benchmark is simply, I'm using for a forecast engine, I use a 13-week moving average, including seasonal parameters. And I use as a policy a 4-week coverage. I didn't optimize that. I just thought about it. It's not going to win. I'm not saying you should use it, but this is 60 lines of code. I opened the notebook. You can see it online. It's just 60 lines of codes, including comments and graphs. So feel free to start with this. Today, Nixtla will show a much better technique than mine. So one of the first things you can do is just to take my code and replace it with Nixtla code and see how it would improve that. By the way, there is a prize for the most community endorsed notebook. For sure, the benchmark does not count in this competition. So if you make a notebook, even if you don't win, you can get a prize. And I really encourage you to share some of your ideas with the community to grow. Last word, I'm not allowed to participate. It's my own competition. I would dream to participate in the competition, but I'm not allowed to do so, obviously. But I hope that some of my ideas will be used. As said, I'm sharing the ideas I have regarding how to optimize inventory policies in my Udemy course. You can use the code VN2-webinar to get a discount. I hope you will, if you decide to follow this course, I hope you will enjoy it, that it will give you some ideas, and maybe some of these ideas might get into the top of the competition. There is one last word that I forgot to include in the slides. So some people will try the competition to win. I think some of you will do it just to learn. I think that's great as well. I hope that most of you will have a lot of fun to do it. It was a lot of work to do it, but it was also so much fun. I'm so excited to see what you, because I'm talking to you, the audience, you can come up with regarding VN2. I'm really, really excited about it. Thank you again so much to be part of this community. There are so many names in this webinar that I recognize. Thank you for being part of this thing and this journey. Nixtla, now it's up to you to show us your models.
Yep, definitely. Thank you so much, Nicola, for the amazing introduction to the problem. And to be honest, it's very inspiring. As we probably have been discussing, we know that to solve an inventory planning problem, the forecasting is the first step for a winning strategy. So next, I'm going to be sharing a little bit about the Nixtlaverse, which is the ecosystem built by Nixtla that will help you in your to build the forecasting model and help you to have a successful step over to the winning strategy. So first of all, what is Nixtla? So Nixtla is a comprehensive suite of open source libraries from Nixtla. So we are offering the state-of-art forecasting tool from a classical statistical model to a neural network, which you can pick up from our library and train the model on yourself. So you can think of it more like a one-stop shop that is offering everything you need from preparing the data to all the way to training the model and to evaluation. So the core library in the Nixtlaverse include the StatsForecast, which is including our classical statistical model, the hierarchical forecasting, which is a probabilistic hierarchical forecasting tool, the MLForecast, which is including the machine learning tools in the toolkit, and finally the NeuralForecast, which is a neural network that you can use to build a model, a forecasting time series forecasting model. So the reason that why you should be using Nixtlaverse instead of other competitor is that first of all, we are offering you a very fast, very optimized performance for across the ecosystem. For example, for statistical forecast, we're offering 20 times more faster solution than other alternative. And secondly, Nixtlaverse solutions are very scalable, whether or not you're going to use it to handle single series or a million of series. It's going to be very seamless and efficient to handle your request. And thirdly, the Nixtlaverse is having tools that is easy to use. It is intuitive and consistent, provide consistent API across all the libraries. It is going to be requiring only minimal setup. And also you're going to see in our example that it's super easy to use. And now we are preparing a series of starter notebooks. So Mariana is going to take over to showcase how you can easily access the Nixtlaverse tools and build a solution as your first step into the competition.
Okay, so well, for joining us, the goal of the as Nicola has already mentioned, is to place inventory orders over 6 consecutive weeks and holding cost. And to decide how much order each week, we need forecast product demand per store. So this is where forecasting comes in. And we are not gonna show you how you can easily use the Nixtlaverse to generate this forecast and then focus on the inventory decisions. We're going to cover how to generate different forecasting models using the Nixtlaverse, and specifically how to use cross-validation for model selection. That was a key insight from the VN1 competition. We're going to follow Nicola on recommendations. We're going to be designing a forecasting strategy around the risk horizon. That is the time you are at risk of running out of stock. We're going to get into more details of this later. So now let me share my notebooks. Now you should be able to see my notebook. So before generating the forecast, it is necessary to prepare the data and have a good understanding of it. So that is what we are gonna do in this notebook. The data set is a CSV file. We just need to load it. And note that there are 2 columns, one with the ID of the store and one with the ID of the product. And the remaining columns contain the actual unit sales from the first week to the last. And to use any of the Nixtlaverse models, we need to convert this data to a long format. This is very easy to do. You just need to fix the store and product columns and convert the column names to a date column and then take the values of those columns. So this is very easy to do, and now we can see that we have 599 time series. The date starts is April 2021, and the data ends on April 2024. Note that the data is weekly and it starts on Monday. And this is going to become an important parameter to define the frequency. Next, it is necessary to do a minimal pre-processing where we check for missing dates, for missing values, and we recommend removing the leading zeros. The first point is already covered just by the structure of the data, since originally every column corresponds to a date. So we know that all series end and start on the same date. We also already missing values, so the only thing that remains in the pre-processing is to check for leading zeros. It's a very basic function that we already created, so we just remove them. And finally, it's a very good practice to check the data, since we actually have a small number of time series. We can do it directly using the plot series function from NeuralForecast. That is another open source Nixtla library. Or you can use this Streamlit app that we created for the competition. This app, we're going to share it in the data source platform along with the notebooks that we'll be presenting in this webinar. And in this app, you can see all the theories at store product level. You can see the total where we can observe some seasonality at the end of the year. And we also added the functionality of checking the data at store and product level. There are 67 stores, and well, you can take a look at them. And products, I think they're around 200 and something. And from these plots, we can conclude that well, there's some seasonality. There's a low sales volume, and most series are intermittent. This means that they have periods of zero sales that correspond to either shortages when there was not product available, or when there were no sales. That is something that needs to be investigated further with the additional information from the competition. But for now, I think we already have a good idea of how the data looks at the target level and at other levels. So let's go to the StatsForecast notebook. This. So StatsForecast is our open source library with statistical and econometric models. And here we're going to show you how to set it up, and specifically how to use cross-validation to evaluate these models on the VN2 competition dataset. We're going to use the AutoRima, the AutoETS, the AutoSES, the AutoTheta, and then there's also another very useful model, the linear exponential smoothing model. But the developer of this model is going to explain it in more detail afterwards. So we're going to exclude it from this notebook. We're also going to include the naive model that in the VN1 competition placed 10th, a very high result. And given what we have seen from the data, we're also going to use StatsForecast models for sparse of intermittent series, Adida, a version of crosstones, IMAPA, and the TSV model. That is a modification of crosstones method. So here I'm just loading the data that we already prepared. Remember that the only thing we did was convert it into this long format, and we removed the leading series. So to get started, we just need to define the models. Some of them require defining the season length, that for weekly data is 52. And in the case of the TSV model, we also need to define these two parameters that define the exponential smoothing that is being
Mariana,
done.
if I may add
Yes.
one word on that, for those of you who know Kruston TSV, the author of Kruston TSV, so T, S, and B, the three of them are participating in the competition as one team. So you would be competing directly against the people behind the model.
Yeah, that's actually announced last week. It's very exciting to have the developers of this model competing. I don't know if Tyler, the author of MFLES, is also participating, but in any case, you can easily use their models in StatsForecast. So now that we have defined the models, we just need to instantiate StatsForecast. We pass the frequency as W Monday. We set the njobs parameter to -1. This is gonna use all the cores of your machine. And we're gonna use as fallback model the naive, although in this particular case, all the series are gonna be forecasted using all the models. There's no model that fails in any series. But it's a good practice to have a fallback model to prevent errors. And this is the cross-validation setup that we're gonna use for these notebooks. The forecast horizon is gonna be 3 weeks. That is the lead time, 2 weeks plus the review period, 1 week. We are using 6 windows since that's the number of rounds, and the step size is gonna be 1. Since every week we're placing orders. So the cross-validation method, we just need to pass the data sets and the parameters, and we're gonna set refit to true, because at every step we're gonna use the data from the previous period. And this is how the output looks. We have for every cutoff date, we have the forecast using all the models that we selected. Now, if you want to go ahead, if you want to see ahead, not just evaluating how the models perform on historical data, you just need to replace the cross-validation method with the forecast method and remove these 3 parameters. You can also add the level or quantiles if you want probabilistic forecast. And now that we have the results, I mean, for this particular data set, it takes less than 5 minutes. The only post-processing step that we recommend is to set all the negatives to 0. Because in this particular use case, it doesn't make sense to have negative forecast. And now that we have the results, we can again use the plot series to look at them. You can use the plotline engine, so it's interactive, and you can select which ones you want to see or you want to remove. For example, if we just want to see how the TSV method looks, well, then we just select that. Just to have an idea of how the models will have performed on historical data, we can use the evaluate method from NeuralForecast. For this particular case, we're gonna use the mean average error. This may not be the ideal metric for this competition, but you can use any loss from NeuralForecast to evaluate your models. I personally like to see not just the mean value, but have more information about the distribution. That's why I use the describe function. And well, in this particular case, for this cross-validation setup, the TSV model turns out to be the most accurate using the mean average error. So this how the results look. Also, the median. If we go for the median, the TSB model is the most accurate. And well, given that the dataset from the VN2 competition has a well-defined hierarchical structure, we have products and stores, and we want to forecast the demand of each product at every store. We recommend you experiment with our hierarchical forecast library, which offers a collection of cross-sectional and temporal reconciliation methods. So let me show you how to use it. First of all, we need to take the original dataset in this long format, and we need to separate the store and the product, which before were a unique ID. And once that is done, we end up with this dataset that it's the same, it just has the unique ID column separated. And we need to create a list of levels that in this particular case is the store and the store product level. There are no more. Next, you need to create the hierarchical data frame. And this is very easy to do with the aggregate function from the hierarchical forecast library. And this is going to create this data set that has the data at all levels, in this case, store and then store product. And it's also going to give you a summing data frame that will be used in the reconciliation, as well as a dictionary with aggregation indices. Well, in this particular case, it's just the stores and then the combinations of store and products. And all of this is very easy to do with just the aggregate function from the hierarchical forecast library. We now need to create the base forecast. Since the best performing model was the TSB method, that's the only model that I'm gonna use. But you can add here whichever models you want. Again, we set up the frequency, the number of jobs, and the fallback model. And please note that everything remains the same. It's just that instead of passing the data frame with just the base level series, we're passing the data frame that we created with all the hierarchical information, which is the series at the store level and the series at the store product level. That is our target. And well, these are the results. As you can see, the forecasts are not just for the product store level, but also for the upper level. That is that is our anchor. So now that we have the base forecast, we can define the reconcilers. There are several of them. Please take a look at the hierarchical forecast library to know more about them. And in this example, we're going to use the top-down level with proportion averages that distribute the top-level forecast using proportions calculated from the average of historical values. So we're going to take the forecast at the store level, and then we're going to distribute it to the product store level using this average of historical values. Once we have the reconcilers, we just need to pass it to the hierarchical reconciliation. This is going to instantiate the object. And since we were using cross-validation, we need to do this small for loop so we can do this reconciliation for every cutoff. And the result is going to look like this. For every cutoff date, we now have the hierarchical version of the TSB model that was done using this top-down approach. And well, the hierarchical forecast gives you the results at all the levels. And to make the evaluation, we just need to take the ones that correspond to the target level. Don't take them all, because otherwise you're going to be considering more series. And using that, and again, using the mean average error, well, we have a minimal improvement over the first TSV method that we use. This is a minimal improvement, but it's just to show you that the hierarchical forecast is very easy to use. And for this particular data set, where there's a very well-defined hierarchical structure, it could be useful to improve your results. If we also look at the rest of the distribution, well, the median is actually better. Also the 75% quantile and also the maximum is smaller. So overall, I think the hierarchical is worth trying. And just to conclude, let me show you that in the app that we created, we also well, in the app that we created, we can also show you. I think I close it, but it's not a problem. We can just run it again. The app that we're gonna be sharing, that is here. Let me just look. You can also plot the model that you generate, and you can add multiples and have a good idea of how the results look at different levels. So with that being said, let's now please welcome Tyler Bloom, that is gonna give us a deep dive into the median Fourier linear exponential smoothing model.
All right, awesome. Well, first off, thank you guys for having me. Hopefully you can see me or hear me. And to answer the question, I will be participating. My team, we are trying to debate on our name, which is obviously the first and most important step of any competition. So once we have that straightened out, watch out TSB. So with that, let me go ahead and share my screen. I have a few slides kind of going over some basic context for MFLES or MFLES, and then I have a notebook, which is some tidbits and tips and tricks that we'll go into. So just give me 1 second. All right, hopefully PowerPoint is visible. MFLES, speaking of names, first off, let me go back. The official logo is this muffin. And one of the biggest controversies with this model is how to say the name. So I've heard like MFLES or MFLES. I'm not saying it's technically correct, but I call it MFLES. So I made the logo a muffin just to kind of remind you, oh, it's a muffin. This is the MFLES model. But my real goal for this is to really give you guys some context, specifically around some of the back end under the hood logic and like the real mechanism going on with MFLES, because it is kind of unique. It's kind of different. And then also equip you with some, like I said, tips and tricks that you can use hopefully in the VN2 and beyond. So first of all, a little introduction about myself. My name is Tyler Bloom. I have a background in econometrics. I know a lot of people, especially at Nixtla, have that background as well. I bring it up just because we've all suffered through econometrics classes. And then beyond that, I began contributing to open source in about 2017. So I went from econometrics to straight into like Kaggles and started seeing a lot of everything was gradient boosting. XGBoost or anything like that. If you had a Kaggle competition, you just ran XGBoost and then threw more computation behind it, and then you win. So that is kind of a theme that you'll see pop up a little bit later with MFLES. Recently, my open source contribution surpassed 1 million downloads. Don't ask me how many of those are bots or my own installations. It's probably very, very high. But I'll just believe that it's 1 million. Very, very excited and proud of that number. In general, I've been demand forecasting for about 6 years or so. I recently joined Daybreak, who's a sponsor for the VN2 competition. Really, our goal at Daybreak is to identify the demand planning process, right? We think that kind of unifying planners with agents and a good MLForecast is a winning competition. And speaking of MLForecasts, we are very, very biased towards the Nixtla suite, mostly because I'm extremely biased towards Nixtla suite. And that's because for some reason, Nixtla keeps implementing my wacky ideas. So earlier this year, I partnered up with Marco, and we extended NBeats to include different basis functions, right? So it goes beyond just a polynomial. Now you can have a change point basis function, for example. And while the accuracy wasn't too crazy in terms of the improvement, it was really cool to see the decomposition of NBeats have those kind of hard change points. A couple of years ago, I partnered up with Jose at Nixtla, and we developed the auto module for MLForecast. So kind of that generic interface into Optuna, so you can do some hyperparameter tuning and tuning for things such as like the lags for MLForecast. And then finally, MFLES in StatsForecast. So I think it was earlier last year, once again, teamed up with Jose, and we got MFLES into StatsForecast, and the rest has been history, I guess. So one question is why MFLES? So I'll just go ahead and go through a few things of why I think MFLES is useful and why you might want to take a look at it, especially for this competition. The first reason is that it gives reasonable default results. I'm not going to say that dynamic optimized theta is better, but I will say that unofficially, it does tend to do better than MFLES on just default settings. But once you have a little bit of knowledge, hopefully from today, you can add some flexibility to MFLES, which is where it really begins to pull ahead from the dynamic optimized theta and some of the other more traditional stat methods. But also it has some promising results from VN1, right? So 4 of the top 20 results use MFLES, typically in some sort of ensemble. And that was tied with theta when it comes to stat methods. Of course, LGBM, just the clear #1 method in general, but a lot of teams were getting good use when ensembling with MFLES. It was a large part of the 3rd place solution. It actually, I think it hurt the 3rd place solution. I don't know if Arsa's in the crowd, but when I looked at the numbers, I think the MFLES ensemble actually performed worse than his just normal LGBM. So I know I've apologized before for MFLES performance, but I'm sorry again for that. But in general, right, so what is MFLES? It is a forecasting method based off of gradient boosted decomposition. So gradient boosted decomposition is something which we'll get into a little bit later. I think it's just the next 2 slides or so. But the name itself comes from the methods that enter the boosting loop. So you have the median Fourier basis, right, for seasonality, your sine, cosines, a linear trend, and then exponential smoothing. Later on, moving average was added as well. It supports things like multiple seasonalities, exogenous features. You can do like seasonal weighting if you want to weight more recent periods more, and so on. So like I was saying, it's a very, very flexible method. So getting into what gradient boosted decomposition is, like I said, this is kind of the underlying mechanism for what makes MFLES work. But it's kind of a generic framework, right? So how does it work? It takes in your standard decomposition where you're going to do some detrending and deseasonalizing, and then we kind of iterate it, right? So we just kind of loop. One other thing we add in are these learning rates, right? So if you look through the whole process in that graph on the right, so we'll take in our time series, we will detrend, we'll apply some learning rate, which you may add, or you may just, not have a learning rate at all. So it takes the full signal. Detrend, then deseasonalize, and then you will basically control for that exogenous. And then you will just have a question, is the cost minimized? So let's just say we are using a mean squared error. The first round, obviously, it isn't minimized, but it'll keep doing this process until a round actually hurts your mean squared error, or it doesn't hit some sort of threshold in terms of improvement. So that's really it in terms of what gradient boosted decomposition is. There is some further reading. So if you want to learn a lot more than you probably ever need to about this approach, there's a link down there at the bottom left. But really the whole point of gradient boosted decomposition is to allow you to put in what I call like exotic methods into a standard decomposition approach that you wouldn't normally see, right? So if you want to see like a double exponential smoother with seasonal naive seasonality and a light GBM for exogenous, this is a framework where you can kind of put those all together. The learning rates and the iterations are kind of the glue that makes it so the outputs are, semi-coherent. Whereas if you don't do things like this, basically once you do anything with light GBM, that's basically the end of the boosting process, right? All right, so tying this back to MFLES, like I was saying, so MFLES is actually just one gradient boosted decomposition procedure that performed well. I like to think it was kind of discovered, right? I was trying out a bunch of different methods in here, a bunch of like wacky, wonky ways to enter methods into the boosting loop and so on and so forth. And this procedure just did well over and over. So I decided to go ahead and package it into a standalone method, add a little bit of bells and whistles, and then voila, we had MFLES, which was born. So with that, I do have, like I said, a notebook where we have a couple tips and tricks that hopefully you can apply to VN2. All right, so hopefully a collab is visible. First off, a lot of this is taken from the actual documentations for MFLES at Nixtla, but I just kind of took out some of the things that I thought would be really, really important, potentially for VN2. So first off, this first cell is basically just your generic parameter settings for something that would be, weekly seasonality. So the season length 52. We have a test size 26. So the test size, basically how you do the auto and auto MFLES is with cross validation. It's not too obvious to me how to really, really optimize something that's being boosted in the loop. I've tried various things, but the best thing was just doing basic time series cross validation. So that's what these parameters kind of all are around. The number of windows, and then the metric that you will use to do the model selection for MFLES. The default is SMAPE. RMSE typically will be better. That default was really just to recreate experiments for M4. Some important parameters here. So test size, like I said, is optimized via time series cross validation, right? So this test size dictates how many periods we're going to be holding out in our each test fold. And then the number of windows dictates how many folds we're creating. By default, we're going to roll through like one period at a time. And then, like I was saying, the metric is the metric that's actually used for the model selection. And finally, this config parameter, which isn't explicitly called out here, but we will get to right here, is the parameter space for different parameters to try out when you are optimizing for MFLES. So by default, if you pass some sort of seasonality, it's going to use quote unquote smart settings based off of the season length, right? So for example, the MA, which is the moving average, it will try the min of your season length because it accepts a list. So let's just say for weekly, we'll just do 52. It will try 52 and also 26, and also none means it's going to use an exponential smoother. I also try seasonality and not having seasonality, and also try seasonality weights. So going through a little bit of what these parameters are for. Seasonality weights, I think I mentioned this a little earlier, but basically if we want to have more recent seasonal pulses counted more and weigh it more in terms of the seasonality, then we would pass true. Otherwise, it's false. Smoother is when we will use an exponential smoother kind of in that boosting loop. And then the MA is going to dictate whether we use a moving average and what the window size is for our moving average. And finally, seasonal period is basically your season length. And finally, getting on to tips and tricks, right? So MFLES cannot handle missing data or NANDs inherently, right? So I would use some sort of filling strategy. Also dropping leading zeros. I know that was in the notebook earlier. Very good idea when doing something with MFLES and just in general with stat methods. You can disable change points for computational gains. Typically, if it hurts accuracy, it's very, very minimal, at least in my experience, but it basically cuts the parameter space in half. I would always experiment with test size and number of windows, also experiment with the MA parameter and the config, right? Try to set it with some sort of like business context, right? So if you're weekly 26, 4, 13, those types of numbers are really good to pass in and try. And then finally use the RMSE metric, change it from the SMAPE to RMSE just for a little bit more robustness and better model selection. And lastly, another call out to Arsa. He introduced me and posted this on LinkedIn a while back, but actually ensembling automuffles is a really, really good idea. It turns out that it's really sensitive to how you're doing these cross validations, right? So things like the number of windows and your test size will drastically change the output of the model. And if you actually pass in a couple different smart parameters settings and then average the result, you tend to get really, really good results. And then you finally get better than a dynamic optimized theta. So I think that's all I have. I will share this out with everyone. Hopefully, you've learned something. You can use this and apply into VN2 and beyond.
I know,
as
before
always,
you leave.
Oh, go ahead.
Yeah, before you leave, it's the first time I can see you in a code. I'd like to thank you for your work. I think on the behalf of the whole community on this new model, it's not every day that you see someone coming up with such an amazing idea. I don't use MFLES myself because of the limitation with missing data that is so important to my clients, but I love so much and I appreciate so much the kind of idea you have about this decomposition, this gradient boosting. I think I never had the opportunity to tell you personally that I'm a big fan of the idea and how you tackle that and the kind of the vision you had for how to decompose it. It's amazing. Thank you so much.
Yeah, awesome. No, thanks for the kind words. It means a lot. Getting a lot of good feedback from the community, but also, helping everyone. Every 1% increase in forecast accuracy is millions of dollars of efficiency, right? So both are good feelings for sure. But yeah, and in general, if you guys have any questions or anything, feel free. I'm always on LinkedIn. I'm always open to talk. But thanks for having me, guys. Any questions?
Yeah. Thank you, Tyler, for this deep dive on muffles. It's good to know that you mentioned the name live. I think it's the first time I hear it.
Yeah,
and,
my biggest regret is the naming part. So the next model, I'll have a much better name, I promise.
Okay, and now please welcome Marco Picheiro. He's an applied data scientist at Nixtla, and he's gonna show the MLForecast and the NeuralForecast notebooks.
Yes, thanks, Mariana. So we are getting a little bit short on time, so hopefully most of you can stay. But otherwise, yeah, I'm just gonna share some code of, so like we said, right, some starter notebooks to use MLForecast and NeuralForecast as well. Let me just minimize this. I have the Q&A tab open, so also feel free to ask any questions as I am going over the code and the methods that I'm explaining, okay? And I'll do my best to answer your questions live. So MLForecast, okay, is gonna work pretty much essentially the same as in StatsForecast, okay? So a lot of the APIs, they're very similar. It's just about the models, how we work with them that is slightly different, okay? So the first part, very similar to what we've done, okay? I'm just importing the clean data that Mariana already showed at the beginning, okay? Plotting it right here. This is all stuff that we know already. So now let's go straight ahead and move on to MLForecast. How do we use it? So first of all, super important, we're going to import the MLForecast object. This is basically the wrapper that we're going to use around any machine learning models so that we can apply them for time series forecasting. And here, as you can see, I'm importing a bunch of machine learning models. So like GBM, linear regression, lasso, ridge, KNN regressor, gradient boosting regressor, okay? So you can pretty much use any regressor model from scikit-learn, like GBM, XGBoost, etc. All of that will work with MLForecast. And then I'm just assigning everything to a dictionary of models so that we can train all of those models and then evaluate them, which one works best. The key when working with machine learning, right, is about building features for your models, okay? So all of those models, they are tabular models, they require features to make forecasts. And so the most basic feature that you can use is lags, okay, which is basically past values of your time series. So it's very simple. In MLForecast, what you're going to do once you instantiate the MLForecast object and you pass your models and of course specify your frequency right here, you can specify the lags. So how many past values do you want to use to make the forecast, okay? In this case, I am passing the past 7 values. Okay, so a range from 1 to 8 gives us 7 values. So I'm going to use the last 7 values to make my next forecast. This is what I am doing right here. And then just like we did with StatsForecast, so once you specify your horizon, number of windows, and step size, you can run cross-validation. Okay, so doing the exact same thing as Mariana did for StatsForecast, just this time we're using machine learning models. Here in this case, I set refit equals to false, okay? Simply to make it faster. Set to true means that at every fold, you're gonna retrain your models. This is usually a good idea. I just set it to false for speed in this case. And we get the following result. So as you can see, so we have the date, right? The unique ID, the cutoff date, the actual value in Y, and then we have the forecast made by all of our machine learning models, so like GBM, Lasso, etc., etc. As Mariana mentioned, right, we are in a demand forecasting scenario. So obviously we want to work with whole numbers, non-negative numbers. So this is a post-processing step that I'm doing right here so that now we get whole numbers only. And then of course you can plot the results against the actual results that you have, all right? So this is, the most basic setup that you can do. Let me scroll back up quickly, okay? So just using past values to forecast future values with machine learning models. That's the most basic you can do. And then, of course, you can run some evaluation, okay? So again, same function that Mariana showed. Here in this case, I'm also showcasing some evaluation metrics that we recently just included in Util's forecast for demand forecasting. So things like the CFE, so the cumulative forecast error, or the PIS, product in stock. So all of those metrics are now available to you as well if you want to evaluate your models using those metrics. And as you can see, so you can see the MAE for like GBM, the PIS, and the CFE for product, 0, 126, so store 0, product 126. So of course you get all of those evaluations individually for each unique ID. Of course, you can aggregate everything if you want later on. So that's it. This is like I said, the most basic way of using MLForecast. Now let's go take a look at more ways of building features for your machine learning models. One of them being lag transformations. So instead of just using the past values, can you use some kind of a transformation or a combination of past values as a feature? So things like a rolling mean or an expanding mean, okay? So here, this is exactly what I'm showing. So I'm importing rolling mean and expanding mean as a lag transform. And so what we are doing is we're going to take the average of past values as we move on through time. And then we'll also do a rolling mean of the 4 last weeks, okay? This is completely arbitrary, right? I'm not saying that this is necessarily a good idea for this scenario. This is really just to showcase the kind of features that you can use and how those functions work in MLForecast. So basically, right, same models list, same frequency. We're still using the last 7 weeks as features, and now we're adding lag transforms as a feature to the model, okay? And then once again, run cross-validation, make sure your values are whole numbers, positive numbers, and then you can evaluate again, and you get those new results right here, all right? Next thing that you can do, date features, all right? So we have time series, so we have data that is indexed in time. It could be useful to know, for example, the day of the week of the year, et cetera, right? So those are all features that you can encode and then use that in your machine learning models. So here in this case, super simple, right? You can just specify in the date features parameter what kind of feature you want to use. In this case, I just put day of week. Not really, like I said, the best decision since everything starts on Monday, right? So all we're gonna know is this is all Monday in the data. But once again, I just wanted to show you how you can use date features in this model, okay, with MLForecast. So once again, just another dimension that you can add to your models to have more features and potentially improve the performance. And then again, cross-validation, just repeating the same thing, new evaluation here. And then lastly, the last kind, in a sense, of feature that you can use is a target transformation. So right now we've been focusing a lot on the past values and transforming them, taking past values, but how about transforming your target? Okay, for example, maybe taking the difference in your target, all right? This is especially useful if you have a target that has a strong trend or a lot of seasonality, then you can take a difference to kind of stabilize the data a little bit. And that tends to improve the performance as well of machine learning models. So here in this case, what I'm saying is, let's take the difference it's actually the fourth order difference of our target, okay? Once again, something that you can experiment with to see which one gives the best performance. And again, run the evaluation and we get new results. So that is a lot of information, right? So now you know that you can use past lags, lag transformations, date features, target transformations. But how do you know which combination is the best, right? Then you need to move on to hyperparameter optimization, all right? So here I'm just going to show you a quick example of how you can run, how you can tune basically your hyperparameters to get the best model as possible. So I'm just going to be using Optuna as the optimization backend in this case. I'm going to be using the auto lasso model. Of course, feel free to use whatever model you want, right? Auto, like GBM, we support that, auto XGBoost, etc. So the way it works, you're going to define a little function that will decide, which feature are you toggling or not, okay? So here in this case, I'm just going to tune two features. I'm going to say date features. Do we use day of week or not? And then target transforms. Do we use differencing or not? Okay, that's the only thing I'm going to tune right here. So that's what you set here, and then you specify the map. Okay, so if you choose day of week, then this is how you write the feature, right, in code. If you decide to none, then you just set it to none. Okay, this is all that we are doing, and then we return the configuration depending on the choice that is made by our optimization. And then once this is done, you can just run, in this case, auto MLForecast. So this is what will trigger this hyperparameter optimization for you and take care of everything. And then super important, you need to define which loss do you want to optimize when doing your hyperparameter optimization. So by default in MLForecast, we're going to use SMAPE, so the symmetric mean absolute percentage error. In this case, not a good idea, right? We have data that is equal to 0 sometimes, so using a percentage error is definitely a bad idea. So here I'm just showing you how you can leverage losses from NeuralForecast to optimize your hyperparameters. So for example, the MAE or the CFE, right? So basically you can just follow this same pattern and use any loss from NeuralForecast that you want. So RMSE, MSE, whatever you want, okay? So once you have that, you can pass the fit method. Again, specify your number of samples. In this case, I'm setting it to 4 because we have only, just so that it doesn't run forever. Okay, feel free to use more samples, of course. And then you specify your loss. So in this case, I am optimizing by the CFE loss. All right. And then once your optimization is done, you can get the best configuration using this line right here. So auto lasso is going to be the name of the model. And then you get the best trial and user attributes config. And then you can see here, this is the best configuration for this machine learning model. So we really optimize two things here. We optimize the lasso model itself. So as you can see, fit intercept is equal to false. Alpha is equal to 3.8. So we optimize the auto lasso model itself. And then in terms of the features, so as you can see, date features seem to help the model. So it was not set to none. However, target transforms was set to none. So using a target transform, so differencing our target, does not really help in this search space, at least. All right. So that's it. This is really how you can get started with MLForecast to make your predictions using machine learning, and also how you can run hyperparameter optimization to tune your model, tune your features, and really find the best combination for your scenario. So now let's move on to NeuralForecast. Again, if you have any questions, in the Q&A, feel free to ask, and I'll do my best to answer. So now just moving on to NeuralForecast, how you can use deep learning to make your predictions. Once again, same setup as before. So I'm just going to go over this pretty quickly. And then you can, once again, this time it's called NeuralForecast, right? So instead of StatsForecast or MLForecast, just going to instantiate NeuralForecast, okay? Import the models that you want to use. In this case, I'm going to showcase NHITS and the LSTM model, and then also import the losses. And here, I really want to show you how to use the Poisson loss, all right? So same setup as before, just now, because it is deep learning, we have quite a few hyperparameters that we can play around with deep learning models, okay? Let's just go over the required ones, okay? So the first one is input size. So how many values are you going to pass to the model to make your forecast? In this case, we're setting it to 2 times the horizon. Then you need to specify your horizon itself, okay? So how far ahead do you want to make some forecasts? Max steps, this is how many steps are you going to train your model for? We recommend usually to set it to 1,000. That is usually more than enough. And then, you know, you can always set early stopping so that you don't overfit your model, but 1,000 steps, usually good idea. Now, for the loss, okay? Traditionally, I guess you could use point losses like the MAE, MSE, stuff like that. Now, because we are in a demand forecasting scenario, again, working with whole positive numbers, using the Poisson loss is going to be very interesting in this case, because now we're going to get our forecasts already as positive counts, right? Positive whole numbers. So very interesting that you can use as the training loss and the validation loss, the Poisson loss. And then you can see here, I'm setting my early stop patience to 3, meaning that if my validation loss does not improve after 3 checks, then we're going to stop training. So, you know, chances are that you will stop training before the 1,000 steps are reached. Scaling your data in deep learning is always useful, right? You have the choice of many scalars. Robust is a good default choice. And then you enter the hyperparameters of the models themselves, right? So the encoder hidden size of the LSTM, the decoder, etc. But basically everything I've said above, so from input size to scalar type, those are all common to all models, all right? And so NHITS, right? Basically the same thing. Like I said, just now we have the downsampling factors, which is specific really to NHITS, but basically the rest exactly the same. So once that this is done, same method, so same cross-validation. So your models are going to be training and then early stopping if necessary. And then you get the following results. So as you can see, so we have 2 things here. We have LSTM and LSTM median. So here really you want to take a look at LSTM median. So this is the median of the forecast made with the Poisson loss that you trained with. So this is already the whole number that you are looking for, right? Same thing for NHITS median. And then by default, we also output the 80 and 90% prediction interval. This is something that maybe you don't necessarily require in this case. And then once again, you can plot the results against the actual values, all right? And so of course here, I showcased LSTM and NHITS. You can pretty much use any model that you want from NeuralForecast, okay? So temporal fusion transformer, NBeats, whatever you want, right? You can use all of the models with the same setup and it's gonna work. And then once again, the evaluation, okay? Same evaluation setup that we've done with MLForecast. And then to conclude, hyperparameter tuning, right? So once again, lots of hyperparameters here. How can you tune them? In this case, I'm showing you how to use Ray, simply because in both libraries, Ray, Optuna, we support both, okay? So I'm just showing one of each here just to show you how it works. So I'm gonna be using Ray, and then you specify the configuration that you wanna search. In this case, I'm using NHITS. So here I put a very simple configuration, again, just for speed. So I'm going to be training for 100 steps, and then I'm just varying the input size between either twice the horizon or 3 times the horizon, okay? Of course, feel free to tune everything that you want. So you can tune the loss that you want, how many steps, you can tune the seed as well, so the initialization seed of the model and all of the hyperparameters of the model. You can tune all of that. Here in this case, wanted to keep it simple. And then the way it works is then you're going to be using the auto version of the model. So here to tune NHITS, we use auto NHITS, all right? Notice I am still using the Poisson loss. Here, you pass your configuration and the search algorithm. Here, basic variant generator is basically a grid search, all right? But because we only have 2 possible configurations, this is only going to have 2 samples. which is why I set my number of samples to 2, okay? If you use a larger configuration, chances are you're going to be using something like the HyperOpt search algorithm from Ray, and then you can increase the number of samples, and that will what that will do is it will randomly sample from the possible configurations, and then it will try to optimize that, okay? So just a little heads up, all of those examples basically are even shown in our documentation in the Nixtlaverse. So once your model is initialized as AutoNHits, you can fit it. And then once the optimization is done, this is a little code snippet that you can use to find the best configuration for your model. So basically, I'm just ordering everything from the lower validation loss to the higher validation loss. So as you can see here, it seems that using an input size of 6, so twice the horizon, is better than 3 times the horizon than 9, okay? So because it achieved the lowest validation loss. This is a bit tricky. Loss really means validation loss. Train loss is the training loss, all right? So yeah, so in this case, just again, show you an example. Input size of 6 gives a better performance than input size of 9, all right? Yes, so input size twice the horizon. Let me just scroll back up quickly. So we set the horizon to 3. So when we say 2 times the horizon, we really mean 6. And it's just common in deep learning to use multiples of the horizon. So, you know, using twice, 3 times, 4 times, etc. It's just a very common practice. So that's why, that's what it means, 2 times the horizon. And that's it. This is what I had to show you for both MLForecast and NeuralForecast. So keep the questions coming in the Q&A. I'll keep answering them by message, and that's it on my end.
Thank you, Marco. I saw that several of you mentioned that to get into the Slack channel, you need a specific email address. We'll change that so anyone with a link can access. And we'll be, if you have any questions regarding any of our libraries for the VN2 competition, we'll try to answer it as soon as possible.
Yeah, thank you so much for all the discussion and all the notebooks. I saw that you're also answering the question in the Q&A session. I think for now, most of the questions are answered. But
yeah, just let me make a comment that I think is gonna answer 2 questions. The first one mentions that cells are censored by stockouts. Won't all statistical models be under bias if you don't censor? Yeah, I mean, that is something that needs to be experimented. I mean, I'm not sure what's the best way of working with that. You can try to use the stockouts information to kind of figure out what will have been the sales on those periods, or you can use exogenous variables. I think there's several models that can use exogenous variables. We didn't show that, but again, it's very easy. You just need to pass the exogenous as an additional parameter.
Just a comment here regarding these shortages. So actually, that was very important for me in VN2 as the mindset I had for the competition to include shortages. When I work with my clients, missing data is supply chain 101. You have shortages, you have new products, you have dying products, you have product which started 6 months ago. I mean, missing data is for me 101 of doing the project with my clients. So initially, I wanted to do that in VN1, but I failed to deliver on that. And for VN2, it was very, very important for me that I could bring you a data set with shortages. As many people commented on data source, shortage information is not perfect. And I'm really aware of that. VN2 is a real data set from a real client. It's been anonymized, but this is real data. And I wanted this data to be real. If the data set wasn't real, there would be no point in this competition at all. So with real data, you get data that at times is not 100% consistent. Nevertheless, the fact that I wanted to bring to the community shortages and missing data. So as a community, Nixtla being part of it, but all other people as well, we can step up our game to include shortages, as we have to make models that cope with shortages really well. And I think we have as a community to learn how to do that and so on. On my personal side with my clients, all my model cope with shortages as the baseline, because it is so common that we have time series with different length with shortages and so on, as mentioned. In a future competition, one of the things I'm thinking about is also to include new product forecasting. So you have to make products that never touched the market before, and then it's just everything's missing, and you still have to come up with a forecast, because for many supply chains, that's what you need to do. You have to come up with a forecast for something that does not exist. Someone is asking, how do we capture shortages? For this specific data set, I do not remember. Different clients measure it differently. What I try to do is, of course, if we have daily or weekly data, it's much easier than if you have monthly data. What I do with clients that have monthly data set is that I'm going to look at the number of days during a month where we ended up with a stock of 0. And if you have more days than a specific threshold, we would define it as a shortage. For weekly data, it's a bit the same. I can look into the number of days within a week where you ended up with 0 stock, and then say that if you have, let's say, 4 or 5 days with 0 stock, or 2 days, whatever, you would consider this as a shortage. You have other techniques as well. You could look at the stock every Monday, and if you have 2 consecutive Monday with 0 stock, you would declare the week as a shortage. These are just ideas. I'm not saying it's perfect, but that's usually how we flag shortages with clients. Not all the clients I have are able to flag shortages. Actually, when you discuss with the client, when you can discuss internally, can you give me back your inventory position for the last 3, 4, 5, 6 years? Many companies can only tell you how much stocks they have today. They cannot go back in time, so it gets difficult. I will put all the notebook online on the competition. You can also share your own version of these notebooks. You can share your own version of my benchmark. You can share your own ID. You can come up with something totally different. I really, as shared, I really wanted to open this competition to anything you can come up with. You can also do inventory policies without forecasting. If you think forecasting is useless, you're more than welcome not to do any forecast. And you can use any kind of technique you think of. If it was not discussed here today, that is no big deal. You can come up with anything you want and give it a try and see how it works on your own, or to basically take part in the competition to give it a try, and we'll see which technique was best.